Welcome back to the next video. So now we're going to be solving exponential equations algebraically or analytically. And this is where we really are going to exploit the one-to-one property of exponential functions. So remember, that's the property of monogamy. Uh, well, for each x, there's only one y, and for each y, there's only one x. So if you've got bases are the same on the left-hand side and the right-hand side, then those exponents have got to be equal. So to solve directly algebraically, what we want to do is we want to try to get the bases equal on the left-hand side and the right-hand side. Then we set the exponents equal to each other, and then we solve the linear equation or quadratic equation, whatever type of equation we get from the exponents. Here is a how-to. If you want to write down these, if you're that kind of a person, go ahead and write down these how to solve an exponential equation algebraically. Given an exponential equation with unlike bases, use the one-to-one property to solve it. Rewrite each side in the equation as a power with a common base. Use the rules of exponents to simplify if necessary so that the resulting equation has the form b to the s equals b to the t. Then we use the one-to-one property to set the exponents equal and solve the resulting equation s is equal to t for the unknown variable. Write those down if you like. If you want to have something simple that says get bases equal, set exponents equal to each other, solve baby solve, that's okay too. So what we're going to do now is, this is a good reminder. This is a reminder from your 7th grade math teacher. Hey, that was probably me for a lot of you guys. I had you do power sprints. It's important for you to become familiar with powers of certain bases, at least for this part of the unit. Powers of 2 are pretty easy to figure out. Powers of 3 and above, maybe up to the 4th power. Sometimes to the 5th power if they're smaller numbers. But it's good to be familiar with these. Put this, hopefully I remember to give you a handout like this to tape into your notebook. But it's good to remember these powers. Powers of 10, you need to know those. The number of zeros is equal to the exponent. Yeah, but let's solve an equation algebraically. So here we have 2 to the x plus 1 is equal to 8. And we want to get the bases on the left-hand side and the right-hand side of the equation to be the same. I'm going to turn on my dual page display on, and I'm going to freeze this one, view pin page. There we go. Now, is 8, so unlike bases, so I'm going to ask myself, is 8 a power of 2? So I come over here, and hey, look, 2 cubed is 8. So what I'm going to do now is I'm going to rewrite 8 as 2 cubed. So now I have 2 to the x plus 1, I'm just rewriting the left-hand side, is equal to 2 cubed. Now the bases are the same, I can set the exponents equal to each other. X plus 1 is equal to 3. And now I have a nice linear equation, so I use my properties of equality to solve it, subtract 1 from each side, and I get x is equal to 2. And that's the solution to the equation. So now I want to check it. I've solved it algebraically. Now let's just verify it graphically. So get rid of that. Yeah, cancel. I don't want to save any of those. So now what I'm going to do is I am going to, the left-hand side is 2 to the x plus 1. So I already have 2 to the x. And now I'm going to stay up there and I'm going to add a plus 1. And the right-hand side is 8. And now I'm going to graph. So there's 2 to the x plus 1. And there's 8. And I'm going to verify that I found the correct solution by finding the point of intersection. So I do second calc, and 5 is intersect. First curve, second curve, guess, and see it says the intersection point is when x is equal to 2. Screenshot, and then boom, copy. And so I have verified this graphically. Copy, boom. I've found that solution, the solution to that equation, and that solution is x is equal to 2. That's the solution. Another one. Why don't you try doing this one on your own? So pause the video, copy down this equation, and then try solving it using the steps I used in example 1. So hopefully you had fun solving that. Let's rewrite this equation as 9 a power of 3. Heck yes it is. 9 is 3 squared. So I rewrite this equation as 3 to the 2x minus 3 is equal to 3 squared. Bases are the same, therefore exponents have to be equal. The equation I get from the exponents is 2x minus 3 is equal to 2. And now it's a linear equation, multi-step. Add 3 to both sides, and I get 2x is equal to 5. Divide both sides by 2, I get x is equal to 5 halves, which is 2.5. I've solved it algebraically, and now I'm going to verify this equation graphically, verify its solution. Come over here, and I'm going to come here. Oh, that's just so annoying. No, I don't want to say that. So I am going to clear out this equation, and the left-hand side is 3 to the power of, and I just do 2x minus 3. Enter. The right-hand side is 9. And now I graph it. And yeah, the intersection point does show up in this window, so I don't have to do any window maneuvers. So now to find the point of intersection, second calc, 5 for intersect. I'm gonna just get a little bit closer. If I move this cursor closer to the point of intersection, it takes the calculator less time to find that point of intersection. And here you can see intersection point x is equal to 2.5. Screenshot, copy, paste, and there I've verified graphically. Yeah, forget the and. I changed it to an or. So that's how you solve, that's some exponential equations. Nice exponential equations can be solved using this technique, where you can rewrite both, or you can write both sides of the equation in terms of the same base. And then you get an equation to solve just by setting the exponents equal to each other. And we can do that because of the one-to-one property because exponential functions are one-to-one functions. Remember, not all exponential equations can be solved this way. Sometimes you might have to solve them graphically or numerically because you're not going to be able to rewrite the bases, or the left-hand side and the right-hand side, in terms of the same base. So here's another type of problem that you might see on a test or in a book. So here we're given f of x is equal to 5 to the power of 2 minus x. Find x such that f of x is equal to 125. What is that asking? Well, I'm just going to parse it down. It's saying f of x is equal to 125. Here is f of x, so I'm going to replace that f of x with 125. So 125 is equal to 5 to the power of 2 minus x. Okay. Now I need to solve this equation for x. The base on the right-hand side is 5, so it's a smaller number than the number on the left-hand side. So I'm going to come over here and see if 125 is a power of 5. Heck yes, 5 cubed is equal to 125. So 5 cubed is equal to 5 to the power of 2 minus x. Bases are equal, so I set the exponents equal to each other. So 3 is equal to 2 minus x. Subtract 2 from both sides, and I get 1 is equal to the opposite of x. Multiply both sides by 1, or negative 1, and I get negative 1 is equal to x. Let's verify graphically. And get rid of this, cancel. Let's say no. And so now my left-hand side is going to be 125. Boom. And my right-hand side is going to be 5, clear, 5 hat 2 minus x. And now I'm going to graph it. And oh, look, I don't see 125 because it's not in my window. This, not the window, but this Z standard goes from, in the Y direction, it goes from -10 to +10. My solution for X is -1. And I know my Y values need to go up to 125. So what I'm going to do, I'm going to set my Y max equal, the maximum value of Y equal to 130. And I'm going to set my minimum value of Y to 120. And then I'm going to graph it. And here you can see where you can see the red function, which is the exponential function, and then you can see the blue function, which is just the flat line, 125. You can see that in the graph. And now I want to find their point of intersection. So second calc, so I got the point of intersection in the viewing window. 5, intersect, blue, and then let's go boom, boom, boom. Second curve, maybe it's that. Okay, I think I need to move. Boom. Well, this is rather annoying, isn't it? I think I'm zoomed in so much that I can't get to that second curve. Darn it. So I'm having technical issues. So what I'm going to do, I could probably tweak my tracing thing, but I'm just going to go numerical here. So I'm going to go table set, and I want my table to start at, let's just start at -1, and let's go up by 1, and let's look at my table. Or no, here's table. And now you can see when x is -1, y1 is 125, and y2, which is the right-hand side, is also 125. So numerically, I've verified that the x-coordinate, or the x-coordinate of the point where the left-hand side function equals the right-hand side function, has an x-coordinate of -1, and that's the solution to, that's the value of x, such that f of x equals 125. So let me take a picture of that. Copy, boom. So I had to verify that one numerically. Sometimes I guess graphing can be a pain, especially with the TIs. With your Desmos, it's a lot nicer. But this is the point of intersection because the output values are the same, are equal at the same input value. Therefore, the solution is x is equal to -1. And there you go. You can solve algebraically and verify graphically.